Today we are going to discuss the second part of the series determining the equation of a quadratic function. Previously, we determined the equation from a table of values. Today, we are going to determine the equation when a graph is given. Let us start. I have here a graph with two x-intercepts. If this is the case, the first thing that I'm going to do is to determine my x values. From this point, point A, my x is equal to -2. I'm going to equate this to 0, so I'm going to move -2 on this side. This will become x plus 2 is equal to 0. From this point, my x is equal to 3. I'm going to do the same thing. I'll move this on this side, so x minus 3 is equal to 0. These two are now my factors, so I'm going to use the factored form. From here, I'm just going to multiply these two binomials. So I have x times x, and that is x squared. X times -3, that will be -3x. 2 times x is equal to 2x. And 2 times -3 is equal to -6. -3x plus 2x is equal to -x. So I have y is equal to x squared minus x minus 6. This is the equation of the parabola that passes through x-intercepts -2, 0 and 3, 0. Let me show you this in GeoGebra. Let me input our equation in factored form. We have x plus 2, quantity x minus 3. So here is now our parabola. Here are the x-intercepts. Let us check it. So correct, we have -2, 0, and the other one is at 3, 0. Notice that this parabola has a y-intercept at 0, -6. Now, what if I'm going to put a factor here, a number, let us say 2. Take a look at the parabola. It changes a little bit, but it still passes through the intercepts -2, 0 and 3, 0. But the y-intercept this time is at 0, -12. Now, let me show you that there could be other parabolas that may pass through that point. So I have here a slider. That would be our A. I'll change this to A. And as I change the value of my A, look what happens to the parabola. It also changes. But the intercepts are the same, -2, 0 and 3, 0. So what if there is a specific y-intercept wherein our parabola passes through? Let us say this one. The parabola passes through the same x-intercepts, but this time the y-intercept is at 0, -12. What will be the equation of this parabola? That will be our next example. So now we have x-intercepts and a particular y-intercept. If this is the case, we are going to use still the factored form. The y-intercept here will be labeled as any point xy. So I'm going to substitute the value of y, which is -12 here. I'll copy equals a, and then x would be 0. And then x sub 1 will come from the first x-intercept. That would be minus -2. It will become plus 2. X again here is 0. And then x sub 2 will come from the second x-intercept. So it will be minus 3. 0 plus 2 is 2. 0 minus 3 is -3. 2 times -3 is -6. To solve for a, I'm going to divide both sides by -6. So this -6 here will cancel out, and -12 divided by -6 is +2. So a is equal to 2. Now that I already know the value of a, I will substitute this in our factored form. So y is equal to 2. We have x minus x sub 1. That will become x minus -2 is x plus 2. Multiplied by x minus x sub 2. That would be x minus 3. We already multiplied these two binomials earlier. Now I'm going to distribute this 2 here. This will be 2x squared minus 2x minus 12. So this is now the equation of the parabola that passes through x-intercepts -2, 0 and 3, 0 and y-intercept 0, -12. Take note of our answer. We're going to check it in GeoGebra. Here is our equation. Let us check if it is in general form. We have y is equal to 2x squared minus 2x minus 12. Same answer that we got earlier. This time we are given a vertex and a point. We all know that a vertex is denoted as HK, and this point here can be denoted as XY. Since I have a vertex here, I'm going to use this time the vertex form. Y is equal to A times the quantity X minus H squared plus K. My Y will come from here, and this is equal to 2. I do not have the value of A yet, so I'll copy equals A. I have here x, and that is equal to negative 4 minus my h is equal to negative 3 quantity squared plus my k is equal to negative 4. I'll simplify this. Negative negative is positive. Positive negative is negative. Negative 4 plus 3 is negative 1. Negative 1 is squared is positive 1 times a is still a. So I have here a minus 4. To solve for a, I'm going to move this on this side. It will become 2 plus 4 is equal to a. And 2 plus 4 is equal to 6. Now that I know already the value of my a, I can substitute this in vertex form. So y is equal to a and my a is equal to 6. I have x minus h. So minus negative 3 will become plus 3 quantity squared plus k. That would be plus negative 4. So minus 4. I'll expand this one first. This will be x squared. 2 times x is 2x times 3 is 6x. 3 squared is 9. Copy minus 4. I'll distribute 6. This will be 6x squared plus 36x plus 54. Copy minus 4. 54 minus 4 is positive 50. This is now the equation of the parabola that passes through the vertex negative 3, negative 4, and a point negative 4, 2. Let's have another example. This time we have a vertex and a y-intercept. Again, vertex is labeled as HK, and I will label this y-intercept as any point x, y. Since I have a vertex, I'm going to use the vertex form. So y will come from y here, which is equal to 8. Again, we do not have the a yet, so we'll copy equals a. Then we have x is equal to 0 minus, we have our h is equal to 3 quantity squared, and then we have plus our k is 17. 0 minus 3 is negative 3. Negative 3 is squared is positive 9 times a is 9a. To solve for a, I'm going to move this on this side. It will become 8 minus 17 is equal to 9a. And 8 minus 17 is negative 9. To solve for a, I'm going to divide both sides by 9. This will cancel out. Negative 9 over 9 is negative 1. So my a is equal to negative 1. Now that I already know the value of my a, I'm going to substitute this in my vertex form. So y is equal to negative 1, and then I have here x minus h minus 3 quantity squared plus k, so plus 17. I'll expand this one first. This is x squared. 2 times x is 2x times negative 3 is negative 6x. Negative 3 squared is positive 9. Copy plus 17. I'll distribute this negative 1. Negative 1 times x squared is negative x squared. Negative times negative 6x is positive 6x. Negative times 9 is negative 9. Copy plus 17. Negative 9 plus 17 is equal to positive 8. This is now the equation of the parabola that passes through the vertex 317 and passes through the y-intercept 08. In this lesson, we were able to determine the equation of a quadratic function when two x-intercepts are given, when the x-intercepts and the y-intercept are given, when a vertex and a point are given, and when a vertex and a y-intercept are given. Now it is time to check your understanding. Pause this video for more time. We are going to determine the equation of this parabola that passes through a vertex -3, 4 and two x-intercepts. There are two ways you can do this. It's either you use the factored form using the x-intercepts and treating the vertex as any point, or you can use the vertex form since we have the vertex and treating one of the x-intercepts as a point. I'll choose the vertex form. Vertex is HK. And then I'm going to choose one point from my x-intercepts. Let me choose this one and label it as xy. So my y is equal to 0. I do not have yet the a, so equals a. And then my x is equal to -5 minus h, so minus -3. It will become +3 quantity squared plus k, so plus 4. -5 plus 3 is -2. -2 is squared is +4 times a will give me 4a. To solve for a, I'm going to move this first on this side. It will become -4 equals 4a. And to solve for a, I'm going to divide both sides by 4. This will cancel out. -4 over 4 is -1. Now that I already have the value of a, I'm going to substitute this again in my vertex form. So this will become y is equal to -1. I'm not going to write anymore the 1. So y is equal to negative. And then I have x minus h minus -3 is +3. Quantity squared plus k is plus 4. I'm going to expand this. This is x squared plus 6x plus 9. I'm going to distribute the negative x squared, -6x, -9. -9 plus 4 is -5. This is now the equation of the parabola that passes through the vertex -3, 4 and one of the x-intercepts -5, 0. Gets? Our next lesson is determining the equation of a quadratic function when the given are the zeros.